Earlier I asked you to do the pre-assessment on science, and hopefully you did it, and I will go through some of those questions I asked you and give you my 2 cents. So the first one is science can prove anything. Well, we wish. Actually, the process of science attempts to disprove ideas, hypotheses, by testing or challenging the hypothesis with observations, the data. And you gather that data from carefully designed experiments. If the idea survives testing, then it is stronger and more likely an accurate explanation. Science is a process which can only produce possible or highly probable explanations for natural phenomena. These are never certainties. With new information, tools, or approaches, earlier findings can be replaced by new findings. And science cannot solve any problem or answer any question. The realm of science is limited strictly to solving problems about the physical world, a world that we can observe with our senses. Science is not properly equipped to handle the supernatural realm, nor the realm of values or ethics, realms that cannot be observed with our senses. Scientific explanations must be potentially disprovable. Explanations based on supernatural forces, values, or ethics can never be disproved, and thus do not fall under the realm of science. Not every study done carefully and based on observation is scientific. Science must follow certain rules. Otherwise, it's not science, just as soccer is not soccer if its rules are not followed. The rules of science are intended to make the process as objective as it is humanly possible, and thereby produce a degree of understanding that is as close to reality as possible. Scientific explanations must be based on careful observations and the testing of hypotheses. So objective is defined as not influenced by feelings, interests, and prejudices, unbiased. Well, we are all people. Objective does not exist, but we can aim at being aware of our biases and minimize them as much as possible. Science can be done poorly, and not anything done scientifically can be relied upon to be accurate and reliable, unfortunately. Science can be done poorly just like any other human endeavor. We are all fallible. Some of us make fewer mistakes than others, some observe better than others, but we are still subjective in the end. Self-correction mechanisms in science increase the reliability of its product, and we'll talk about these self-correction mechanisms a little bit later. Different scientists may get different solutions to the same problem. And science can be influenced by race, gender, nationality, religion, politics, or economic interests of the scientist. That's true. Intentional or unintentional sources of bias introduced in a study can result in different solutions to the same problem. Scientists are people, and although they follow certain rules and try to be as objective as possible, both in their observations and their interpretations, their biases are still there. Unconscious biases, sources of funding, political learnings, can and do influence one's perceptions and interpretations. Unfortunately, science is all too frequently misused. Because it works so well, there are those who apply the name of science to their efforts to prove their favored cause, even if the rules of science were not followed. Such causes are properly labeled pseudosciences. Also, some scientists have been known to do fraudulent work in order to support their pet ideas or for financial gain. Such work is hopefully exposed sooner or later due to the peer review system and the work of other scientists. Knowledge of what science is, what it can and cannot do, and how it works is important for all people. People need to be able to evaluate scientific information and make decisions about the information. Scientific information is used to support political arguments, advertise products, and inform people and factors that affect their health. It is important for all people to be scientific literate in order for them to be able to think critically about what to vote for, what to buy, and how to protect their health. Given that science can be poorly done, what is good science? Objectivity is the key to good science. To be objective, experiments need to be designed and conducted in a way that does not introduce bias into the study. But as discussed before, that's easier said than done. So exactly what is bias? It is a prejudiced presentation of material, a consistent error in estimating a value, and there are two main types of bias in science: sampling bias and measurement bias. Let's talk about sampling bias first and clarify what a sample is. Let's say you want to find out the average height of students at City College. It's not practical to measure all 80,000 students, so you would take a sample of some students and extrapolate your findings. Sampling bias is introduced when the sample used is not representative of the population or inappropriate for the question asked. So the first one, not representative of the population, would be if you sampled the basketball team's height and think that that is representative of everyone. And inappropriate for the question is a good example from the medical field. Most commonly, the efficacy of medications was tested on white males only, assuming that white males are representative of everyone. Turns out that medications might act differently on women and on people from other races. So the sampling was not appropriate for the question whether this particular medication works well. It would have been okay for the question, does it work well on white males? Factors that contribute to sampling bias are sample size. So to determine the average height of City College students, how many students should you measure to get the best estimate? If you only measured 3, will your mean be accurate? Sample selection is what we just discussed before. Is the sample that you chose really representative of the whole? And you have to take into consideration factors such as age, gender, ethnicity, and so forth. So how can we minimize sample selection bias? One is to use a random sample. Every individual has an equal likelihood of being chosen. So you can do that by flipping coins or dice or a computer program to assign individuals to particular groups. And the other is to limit the question asked to the specific group sampled, as I said in this example of testing medication on just white males. The second type of bias was measurement bias. So it's the question whether the method of data collection is chosen so that it really matches reality. And questions you have to ask is whether the measurements were taken accurately. Did you use a measuring tape that is not broken? And that there were no additions to the environment that will influence results. An influence to the environment, for example, is if you have the measurements of people with shoes of different heights. So that might bias your results. And the last and really important factor here is that experiments need to be designed so that they isolate the effect of multiple factors. For example, if I propose the hypothesis that students that sleep more than 7 hours the night before a test will perform better on the test, and if I ask students to report how much sleep they received the night before and then compare this with their test scores, and if I don't ask about other factors such as how much did they study and whether they ate breakfast, how can I know that any trend I observe is reflective of how much sleep they received and not on the other factors? So in summary, good science depends on a well-designed experiment that minimizes bias by using the appropriate sample size, sample selection, and measurement techniques.